These notes are going to deal with the topic of direct variation and inverse variation. You'll notice the key information that you need is in the chart right below the title. Right? And there's a couple of things I want to highlight for you so that you make mental note of these. These topics are not that difficult to separate in your mind, but you have to know what each one is about and the details surrounding each one, both graphing wise and equation wise. So we'll start with the graphs. In order to have a direct variation equation or graph, the first thing that you will notice or should notice is that the graphs always go through the origin. So when you're looking at a line and you're trying to figure out whether it's direct variation or not, look for the origin and see if the graph will go through it. If it does, then you definitely have one. If it doesn't, you know you don't. Okay. And then in the equation world, the formula you need to memorize for this, because remember I told you there's several of them in this chapter you will have to have memorized, is y equals k times x. Right? The other one just solves it for k, which we are certainly capable of doing that on our own without having to break up any other pieces. The second one is the inverse variation, and your graph will always curve on this one. So it will look like an exponential curve, but it's not really. Okay. And the equation for this, or the formula you need to memorize for this one, is y equals k divided by x. Right? So, and if you think about it, the inverse of multiplying is dividing. So a direct variation has them directly multiplied together. An inverse variation has them done opposite. The opposite of multiplication is division. Right. The next thing we want to fill in is some key vocabulary. The constant of variation, which is known as the letter K in these formulas. So every time you see the K value, that represents the constant of variation. And it's also known as the slope. So slope and constant of variation are synonyms for each other. So when they ask you to identify the constant of variation, they're really asking you for what is the slope of the problem. But instead of using the letter M, like slope is normally written as, the letter K is used for constant of variation. Okay? And once again, there are two types of variation. There's the direct variation and the inverse variation. These are the two types you will have to work with and identify throughout this course. Okay, for example 1, right, you are given two pictures, and again I will do one part of these and you will be responsible for answering the other part on your own and then coming to class and we will check over what you came up with. Right. The first example is asking you from a graph to find the constant of the variation and the slope of each direct variation. So they're already telling you the direct variation, and if you look at both of them, we can confirm that because they both go through the origin. What we need to do next is to find the constant of variation, which is the exact thing as the slope. So you're only doing one thing, even though it sounds like they're asking for two. Right? So to find slope from a graph, you simply do rise over run. So we need to find 2 points. Obviously, the origin is a certain point on the graph, and then if you find the next intersection point, okay, you can do your rise over run. So if we rise 3 and run 1 to the left, you've got 3 over -1. So your k value or your slope for this line is -3. So you try number 2, and again, all you're doing is finding the k value, which is the slope. Right? In example 2, they are giving you an x value and a y value, and they're asking you to write an equation that relates them either directly or indirectly. Okay, so for number 3, I will do 3 and 4 with you. You do 5 and 6 on your own. But for number 3, it is asking you to write an equation where x and y vary directly. As soon as you see the word directly, you know you're using direct variation. So you start with the formula. The formula is y equals k times x. Well, in order to write an equation where the value of k is a number, you have to figure out what the value of k is. So this is where we're going to use the given statement of x is 2 and y is 4. We're going to plug in those values in the correct spot. So we have 4 equals k times 2. And to solve this for k, we would divide by 2, and we find out that the k value is 2. Now that's the value of k, but that's not the equation. To write the equation, you go back to the formula and take the letter k out and replace it with what you just found. So the equation that is the official answer to this is y equals 2x. This direct variation equation satisfies the answer to number 3. For number 4, we're going to do the same thing, except for this time it says inversely. So that's your clue that you're using the inverse formula, which is y equals k divided by x. And once again, you're still using the x is 2 and the y is 4. Until they give you new numbers, those are what you're going to use for the problem. So for y, we make it 4. leave k in the right spot and put 2 in the x spot. To solve this one for k, we're going to multiply both sides by 2. 2 times 4 is going to give you 8. So now you have k equals 8. But once again, that is only your constant of variation value. That is not your actual equation. So you go back to the original formula, take the letter k out, and replace it with 8. So the correct answer will be y equals 8 divided by x. And that is the inverse variation equation for number 4. So you try numbers 5 and 6, this time using the value of x is 3 and y is 12, and see what inverse and direct equations you come up with. If you flip it to the back side, example 3 is going to have you doing a little bit more of the same stuff, but then it's going to ask you to use the equation that you generate to apply it to another value. So I will do number 7, and then you will have number 8. For number 7, it tells you the values vary directly, so I know I'm using y equals k times x. Okay, and this is for part A. And I need to write an equation that relates the x and the y. So they told me the x is negative 3 and the y is negative 30. So I replace my x and y. Negative 30 equals k times negative 3. I solve it for k by dividing by negative 3, and I come up with k equals 10. Okay, but notice that in letter A it asks me to write an equation. So an equation would be taking the k out and putting the 10 in. So the equation that answers letter A is y equals 10x. Okay, and now that I have the equation, I'm going to use that to help me do letter B. For letter B, it says find the value of y when x equals 8. So I'm going to use the equation that I just generated, and in place of the x, I'm going to put the value of 8 because that's what it told me to use. So I've got y equals 10 times 8, right? And you would come up with y equals 80. Right? So you're using an equation that you have actually come up with on your own to find the value of another number. Okay, so you try number 8, and notice that number 8 does say inversely, so make sure you're using the correct formula when you go to do that one. Okay, for example 4, you are comparing tables to describe if the data in that table shows direct or inverse variation, and then write an equation that does relate those values. Right? So the first thing we want to figure out is what the pattern is amongst the values. So if you look at number 9, if I go from 1 to 2, I'm adding 1, and that pattern exists all the way across. And then if I go from my y's, I'm going from 2 to 4, which is plus 2, plus 2, and plus 2. So the pattern is the same. And remember, in order to find our pattern, it's always y divided by x. So in this case, it would be 2 divided by 1, or just 2. Right? So the value or the pattern that goes in front of the x is 2. Okay? And then we need to figure out where we start. Well, if you go backwards to get the x value of 0, okay, then if I go backwards from 2, I'm also going to end up with 0. So noticing that 0, 0, which is the origin, is in your equation, is going to tell you right away that your equation is direct variation, and the equation is y equals 2x. All right, so this would be known as direct. All right, for number 10, I am going to do this one with you just because I want you to see the pattern and the difference between the two. Right? If I try to figure out the pattern between my x's and y's, you'll see how there's a difference. To get from 1 to 2 is plus 1, and that's normal. You can tell that all the way across. But then to get from your y values, you'll notice that something's happening. From 8 to 4, I am subtracting 4. To get from 4 to 8/3, though, I'm not subtracting 4. There's not really a tremendous pattern there that you're going to be able to follow. Right? So we want to be careful on how that works. What we want to figure out is what's happening to the x to get to the y. Right? So we need to back up a second. Okay? We know the origin is not going to be in this problem at all. Right? So just because the origin's not going to be there, we can already tell that it's going to be inverse. And with inverse, in order to create the equation, right, we have to have it under the formula y equals k divided by x. So pick any two values, your x and your y. I'm just going to stick the first one in, and find the equation. So the first thing you have to do is find the k value. So if I put 8 for the y, k is k, and then divide by x, which is 1. You're going to multiply by 1 on both sides, and that confirms that your k value is 8. So if I go to my equation, it's going to be y equals 8. Y equal, 8 divided by x. And if you test it out, right, 8 divided by 1 is 8, 8 divided by 2 is 4, 8 divided by 3 is 8/3, 8 divided by 4 is 2. So it does work, right? But you've got to figure out from looking at your tables whether you're dealing with direct or inverse variation. It's a lot easier from the graphs. The tables are a little harder. Okay. For example 5, I'm going to show you all 3 of these. right? And what's happening with this is that you are actually taking a situation and determining whether it's direct, inverse, or neither one. Okay, and sometimes this is a little tricky because they use different letters of the alphabet and you have to figure out which one is pretending to be the X and which one's pretending to be the Y, or is neither thing happening. Okay, I'm going to start with number 13 first, and you'll see why once I start talking about it. If you read through the whole situation, they get to the equation B equals 8 minus D, right? In both direct and inverse variations, there's no subtraction. So that's a dead giveaway for number 13, that this is obviously neither one of them. So we can get that one out of the way. Now we want to take a look at numbers 11 and 12. And if you stick with the formulas given to you, it'll help you out a little bit more. So in number 11, the formula they gave us for area of the base and height of a prism is BH equals 10. Okay. And obviously they want you to relate the two areas, or the two variables of area and height, right? So height is going to be I'm going to call my X value, and the area of the base is my Y value, right? So if I solve this for Y, I have to divide by H in order to get the B by itself, right? And then that leaves me with B equals 10 over H. And if you switch my B and my H to the X's and Y's, then really that turns into Y equals 10 over X. And it looks and resembles the formula of inverse variation very nicely. So this would be an inverse variation problem. Okay, so let's see if we can take number 12 and do the same thing. They gave you the formula of 2V equals M. Okay. And with that, we need to figure out who is acting as the X and who is acting as the Y. Okay. And in this case, if we take and look at it, right, it tells us that they are related together and that the density is twice that of the substance. Right. So if we take and think of our volume, okay, as our X and our mass, sorry, as our Y value, right, it is written as Y equals 2X, which when it's written that way, you're pretty safe in telling the difference between inverse and direct. This obviously is going to be a direct because it looks very similar to that direct formula. Right, so taking situations is not always the easiest, but anytime you have a constant multiplied times a letter like this, it's very much more likely to be the direct variation kind than it is the inverse. When the two letters are multiplied together, most of the time you're going to have inverse variation going on, but there are the occasional times where it does switch gears and it becomes the other. But the giveaway for the 13th one is that it cannot be neither one because there's no addition and no subtraction in direct or inverse variations. Right, so we're going to practice some more with writing these equations in class, but this is the gist of where you're going. So make sure you complete all the ones that I did not do with you in this video, and then come to class prepared to figure out what you still need help with or what you're okay with.